The Japanese research lab Sakana AI just released a research paper introducing a new inference time-scaling algorithm that uses multiple AI models with a sophisticated algorithm to solve the most complex problems, sometimes even ones that the smartest AI models struggle with. What's really impressive is that with this algorithm, they have achieved significant performance on the AlphaGo benchmark, almost beating every other frontier AI model. The AlphaGo benchmark is significant because it suggests their method is genuinely improving an AI's capacity for reasoning and generalization, which are key steps towards AGI. Sakana Lab developed an inference time-scaling algorithm called Multi-LLM AB-MCTS. Here's how it works. When you ask an AI to solve a problem, it immediately generates an answer based on its training. When there's a really complex problem that needs to be solved, our usual go-to is to use chain-of-thought models. That's like the AI thinking step by step, but it's still just one path. The two traditional paths for improving an AI's performance at inference time are, first, sequential refinement, when an AI already has an initial output or partial solution and starts to refine and iterate based on that existing output. The problem with that is if the initial output is wrong, it's going to be a mess. The second option is repeated sampling, where you ask the AI to solve the same problem multiple times. After having lots of outputs, around 50 to 100, you verify the correct one. AB-MCTS uses an algorithm like the one in AlphaGo, called MCTS, to decide which step to take next for better performance, sequential refinement or repeated sampling. At every step of the problem, its job is to decide whether to generate a brand new answer, repeated sampling, or make the current one better, sequential refinement. Then, they add another layer by having multiple frontier LLMs work together on a problem, which they call Multi-LLM AB-MCTS. On top of choosing the search direction, it also selects which LLM would produce a better outcome for the current stage of the problem. The first step of the Multi-LLM AB-MCTS algorithm is to select whether to go deeper or to go wider. If it decides to go deeper and explore the current idea, the next step will start again at step 1. But if it decides to go wider and generate an entirely new solution or approach, it moves to step 2. Here, it dynamically chooses an LLM it thinks is most likely to succeed for this specific next step, based on what it's learned about each AI's strengths so far in the problem-solving process. The LLM then uses the context from the parent node to generate a solution, which then gets evaluated and put into the growing search tree for the ultimately accurate solution. They discovered that while DeepSeek R1 does not perform particularly well on its own, combining it with a Multi-LLM AB-MCTS efficiently increased the number of solvable problems. They also noticed that problems that were unsolvable by any single LLM were solved by combining multiple LLMs,